we've had Roger with us before. You know, he did a great presentation for us back in, gosh, I think it was in June, if I remember correctly. Anyway, earlier this year, I think he had about almost 1,000 views on our YouTube channel, and that was on long haul sporadic E, which was, gosh, just a fabulous program that's just, you know, been such a source of reference for me for a long time now. And so, you know, today's is going to be about F2 and what all the elements are that go into it. And, you know, it's not just the solar flux. So Roger has a long history of working in propagation. You know, he started out years ago working down in Antarctica, studying aurora, and he's been a communications engineer for many years and quite active in all the clubs and publications in Australia. You know, he's the editor of a couple of publications currently, and he's also worked for the Australian Space Weather Bureau. So he's very well qualified to give us this talk. And I'm looking forward to it.
Factors influencing F-layer, and I've added the little ride. Good, thank you. As solar cycle 25 peaks. So let me give a bit of a roadmap. First of all, with our sun. I think almost everybody is well aware of that. However, we get surprises from the solar cycles and the sun's influence on our ion. Winter is not always discontenting, just to sort of paraphrase William Shakespeare. Mindfulness, path elevation, and antennas. I'll cover the importance of azimuth and the opportunities from precursors. So, solar cycle. Are we there yet? Well, if you look at all the past solar cycles, there's big ones and small ones, and a lot of people are saying, well, there's a bit of a trend going, and it's all downwards. Maybe, maybe not. That's the bit about the sun. It has these surprises for us. So where are we at? This is the International Sunspot Progression from the Royal Observatory of Belgium, which is the World Data Center for solar data. So on here you can see the smooth line and the monthly progression of sunspot numbers, as well as the daily. So the lighter, the yellow one is the daily, which of course is highly volatile, but even the monthly ones are volatile. The forecast there, the dashed lines, there's two, one above the other, heading off to the right. Which one's going to transpire? So the solar minimum was in December 2019 with a smooth sunspot number of 1.8. Seems unbelievable. Now the 2024 forecast for April to July, this is from the Australian Space Weather Services, is from 142.9 to a bit over 147. So we look at the table of what's been happening to date this year. The sunspot number has, this is the smooth number, the observed number every month. So it's been climbing well above the forecast from May through to August. September, it may be reviewed, but it was down. Where are we headed? Well, the observed smooth sunspot numbers exceed forecast regularly, and it looks like that's going to continue. We may be going through a solar peak right now, or it might be yet to come. So here's another graph for you. Shows the comparison between the last solar cycles, SC24, and the current. So the spiky chart is the monthly smooth sunspot number, and the plain line, they pointed out there, is the smooth numbers, smooth over 13 months. So we're climbing well above where we were back in solar cycle 24. Now you note there are two humps. Maybe we're in for a second hump, or maybe we're in the second hump. All good fun. So, as I said, the smooth number is well above that for solar cycle 24. So, here's the sun pumping up our ionosphere. Circulation is very important, as it is with us. Solar radiation drives the thermal tide, as you can see to the lower left there. So that expands the atmosphere and the ionization in the ionosphere, which travel away from the sun. And the magnetic equator is very important. The thermospheric winds from polar cap processes excite plasma waves with periods of 2, 5, 10, and 16 days, which wash through the atmosphere and the ionosphere just to keep things moving. We also get gravity, or you might say buoyancy waves, from atmospheric shocks. That might be volcanic eruption, it might be a large thunderstorm, and these ripples travel up through and horizontally through the atmosphere, right through to the thermosphere, where we have the ionosphere. In other words, the ionosphere is blowing in the wind, with acknowledgements to Bob Dylan. So season's a factor. The winter anomaly is your friend. Here we are. A recent graphic from QST, which is in fact a modelling of an east-west path, 4,000 kilometre path. The F2 layer. You see the dashed line with arrows tells you when 6 metres is likely to be open. Now this is for a sunspot number of 100, the red line, and for this, the minimum year, the blue line. So we're right in the middle of it. But this is for the northern hemisphere. What about happens down here? Whoop, sorry, I'm getting ahead of myself. What happens when the sunspot number goes above that 100 of the last graph? Shall we say to 180? Well, graph moves upwards, or the frequency bars move downwards. So you get a much wider opportunity with many more months. And here's the path. Now it's very important that it's a very low angle path. Scars are exaggerated for the purpose of illustration. So 4,000 kilometre paths, mid-latitudes, North American region. Path elevation is tangential to less than 2 degrees. We get more F2 layer ionization because there's more oxygen ions available relative to nitrogen, which are heavier, from seasonal circulation in the ionosphere. As I said, circulation is important. With the solar cycle number, with these smooth sunspot numbers from 100 plus, 6 metre F2 may open between or over fall to winter, early spring in your part of the world. Now, it's also experienced in the mid-latitudes for the transatlantic or trans-Pacific areas. So what happens down under? Catch up with myself? Well, the curve sort of flips horizontally. And for the high solar numbers we have at the moment, we get a wider opportunity, many more months, because our winter is in the middle of the year, June, July, August. So from late March through to early August, we get opportunities for F2 propagation at these sort of sunspot numbers. Here we are, MUF, 4,000 kilometre path in our region. Autumn fall runs over March to May, winter over June, July, August. Only a small overlap with North America. So late March, early April. So that's the opportunity for between hemisphere F2 propagation. Again, scales are exaggerated for the purpose of illustration. So what matters next is antenna elevation angles. Here's a couple of case studies I've done. It's a 3-element 6 metre Yagi mounted 10 metres off the ground in the left there. The peak of the gain is at 8 degrees. And typically for a 3-element Yagi is 14.5 dB isotropic. On the right, let me get rid of this in my way here. On the right, we have an 8-element Yagi 20 metres above ground with a typical gain of 19 dBi. And the peak of the gain is at 6 degrees. So if you've got a lower elevation angle on the rate path, you're working on the bottom of those first lobes. Keep that in mind. So 6 metre DX propagation paths are inherently low angle for both F2 and sporadic E. Your antenna is working at the bottom of the first lobe. Now, we get to the equatorial ionospheric anomaly. It's a bit of a mouthful. So this is what it looks like if you look at the electron density or the vertical reflection frequencies, FOF2, for those that are familiar with it. You get this double peak either side of the geomagnetic equator, typically at plus or minus 20 degrees geomagnetic latitude. Now, ionization builds up either side of the geomagnetic equator because of the influence of the sun and the thermal tide. Can't see myself here. So it displays symmetry at the equinoxes. further on. Now, this is what it looks like from a global perspective. So this shows equipotential equipotential lines of ionization in the ionosphere. So you can see that. You can see the red ones where it shows the peaks. Now, this, of course, is not. This is a bit asymmetric, and it favours the northern hemisphere. But nevertheless, you get a lot of opportunity arising from that. Solar radiation and the ionospheric convection maintain the latitudinal extent that you can see there. Production of the EIA follows the sun westward. So still having trouble here with this. Right. So we get trans-equatorial propagation. This gives you opportunities for interhemisphere, as I said earlier. So here your typical trans-equatorial propagation that depends on the equatorial anomaly, those peaks in density either side of the geomagnetic equator. This is afternoon type or supermode TEP. A caudal hot propagation path with ray path focusing, which is an interesting phenomenon because that gives rise to gain as you go through the ionosphere. North-south paths are typically 4,000 to 7,000 kilometres. Oblique paths more than 10,000 kilometres. So here we are with ray path focusing. This, in fact, is a tracing of a real measurement of what was happening at the equatorial anomalies and what was happening with signals arising from Seoul in Korea and being received in Townsville. Although in this case, you said that focusing on the right-hand side is a bit above the ground. Nevertheless, it does come to ground. I have personal experience of it. So this shows the focusing effect here. Now, I've had experience of this working in Townsville at one time. Two local amateurs were sort of like an urban block apart, north and south from one another. So in the northern shack, we could hear a really good signal. And his friend in the shack one block to the south could not hear the signal. And then it faded in the northern shack and rose in the southern shack. So I could walk between the two shacks and follow the focal point. Fascinating. So here we are with some paths. So we get, oblique paths like that. Now we get to an interesting bit with longitudinal propagation using or exploiting the equatorial ionospheric anomaly. As you can recall from a few slides back, if you go for a holiday in Peru, you can work the Cook Islands. You could certainly work Hawaii, and it's been known to work the Philippines from the US using this path. So, where are we so far? Our opportunities and experiences are controlled by the sun. Solar cycle 25 may be picking, or yet to do so. Winter winds are the winners. Ray path elevation is smaller than you think. Azimuth matters more than elevation. Development of the EIA brings opportunities. The equinox is a good neighbour. So as you go through the winter anomaly, close to the equinox, you might get some TEP. So are there any precursors? Are they a factor? A number of people, keep an eye on 28 megs. Well, here's an interesting chart. I have a friend in VK3 in Victoria, 1,000 kilometres, 1,200 kilometres south of here, who has a bistatic backscatter chirp radar, and published the work in Dubis and in other places about how he's developed it. It just uses ordinary amateur transceiver, 50 watts, standard voice bandwidth, and he emits chirps and has digital processing of the return signals. Now this one's interesting because he took this on the 15th of May and he worked W3XS in Idaho at the same time. So this, of course, is well about our time now, actually, except we're in the opposite month. So this gives a good idea of the condition of the F layer, which is pretty good. So that can come as a good precursor, because you get into a whispering gallery mode in the F layer, F2, because of some interesting mechanics. If the F1 layer is at an appropriate height and an appropriate density, it will turn the signal, deflect the signal at a sufficient angle such that it enters the F2 peak at a very, very small angle and becomes a whispering gallery. Of course, it will exit at wherever there's a discontinuity. So the F1 layer deflects the ray path at a critical angle. Yep. Right, I'm getting ahead of myself here. There we are. So with FOF1, which is of course the reflection frequency directly vertical, but the FOF1 is between 4 and 5 megs, and the height of F1 at about 90% of the F2 layer, that it provides good conditions to get this whispering gallery mode and around the world propagation. And here's a good way of predicting it. This is a mid-solar cycle, so probably a smooth solar cycle number of 80, 70 or 80. The little graph on the lower left represents the sort of angles you need to enter the F1 layer, or the point that you enter the F1 layer, and that gives you the exit angles. That the angle beta. It's very small, as you can see, but if you pick frequencies, you get these inverted parabolas. So that source altitude represents the F1 region. So you get a good view of what happens. Those lower frequencies, you get ATW, you get fewer opportunities because the right-hand side there, 50 megs and 60 megs, because the angles need to be very much closer, very much smaller. So primary factors went on the air. The solar flux index is your friend. SFI of 120 to 150. Oh, my spelling's gone off. Improving in most. SFI of 150 to 200. Excellent MUFs. 200 to 300 is pandemonium. Keep a close watch on the A and K indices. Low values equals quiet time, so you can hunt and pounce. High values, geomagnetic storms, return to your knitting. And to paraphrase an old music hall ditty, "'Tis the flux what gives the pleasure, but the flare's what brings the pain." Thank you. What are we doing? Exit. There we are.
So do we have questions for Roger?
Yes, I'd like to ask a question.
Please, go ahead.
Okay, can you hear me? WA1SXK, Eric.
Yes.
Okay, hello, Roger. Thank you for your presentation here. Very good. Can I ask you, do you have any information about the height of an antenna? I guess well, an LFA 4-element beam. Didn't mention, but does the height, I don't think you did, but the height of the antenna above the ground, does that affect the angle that you talk about? It looked like in your graph, working 6 meters, it was a little bit over 4 degrees was the best possibility of working 6 meters. Back to you, Roger.
Yes, the height does matter, as I showed you in those two diagrams. But even if you get it to 50 meters, you only lower that lobe by another degree or so. That's ground reflection is your enemy here. If you can get a negative horizon, which in fact my friend with the chirp radar has with his receiving or his remote station, he has a negative horizon for most directions. That improves it, but it doesn't go down to zero. It just means that you get a little further up the gain side of the first lobe. You're never going to do any better unless, of course, you do it from an aircraft at 5 or 10,000 kilometers.
Okay, thank you very much, Roger.
This is John,
So,
FOYE.
3-element Yagi. Go ahead, John.
Thank you, Roger. Roger, I'm in an HOA issue, so I have attic antennas, and I will be installing on a fan dipole. I will be installing 6 meters at about 18 meters, I'm sorry, 6 meters above the ground, so about 18 feet. And what are your thoughts on the viability of that?
Well, it would be viable, providing the signal path is really strong. And don't forget, if you get focusing, which is more common than we think, you get an improvement in signal strength. So don't despair. As I pointed out in the illustration, the 3-element Yagi tethers above the ground. My friend, the VK2ZRH, unfortunately now a silent key, he had it in a suburban house just above his roof. So there was a lot of nearby clutter, but nevertheless, he was able to work. He managed to work UK, Europe, and USA from there with an antenna with not much gain and barely clearing his house. So it's don't despair. You know, give it. If you go on there, you're likely to work something.
All right, thank you.
Roger, I have a similar question, if I may. So I'm kind of in a restricted area too, in terms of we don't have a HOA, but we have covenants and restrictions. And I've been running a DX Commander. And in May, I worked Argentina on 6. May 6th, I worked Argentina, worked several Argentina stations. I think it was Ecuador as well. You know, the Argentina was 6,000 miles, I believe, 5,000 or 6,000 miles. I guess I was probably trans-equatorial. And I was wondering, I've read a lot of stuff about low angle irradiation using a ground DX Commander actually. And it's supposed to be really good for that low angle radiation. And I was wondering if you had any comments on that.
Yes, that's another way to go about it. But nevertheless, ground reflection from in front of your antenna or in the direction of propagation will still tilt up the gain profile. So it's you can model it, and the models look really good, but when you add reality in, it's not so good as you think. But nevertheless, you do get an advantage with low angle vertical with a ground plane. It's important that the vertical work against a ground plane rather than what is often called end-fed verticals.
Okay. Yeah, it's not an end fed because it's ground mounted radials, right? But I guess get it up in the air is what you're saying. I'm sorry.
Yeah, yes, get it up in the air.
Get it up
Back
in
in my early days, I'm talking 50. Yeah, back in my early days, when first on the air as a teenager, I built a 3/4 wave vertical for 6 meters. Now this has 2 lobes. It has a high lobe and a low angle lobe, and that was very successful. I could work short skip sporadic E on the high lobe and long distance stuff on the low lobe, and it was you're only getting 1.5 dB of gain, but it worked spectacularly well. And I had a number of course, other people on the air who didn't believe it, but nevertheless, I proved that you can do it and it works. So that's another thing to think of is a 3/4 wave rather than a 1/4 wave vertical.
That's what I've got. Actually, I put a 3/4 wave rather than a 1/4 wave on it. So it is 3/4 wave.
Oh, excellent. That well, good luck with that.
Worked a little bit.
Hearing no further questions, Roger, thanks an awful lot for another great and extremely timely presentation for us. A lot to digest there. And I'm glad we were able to overcome any technical issues and take care of our internet propagation in order to get you to our group tonight. We'll be putting your program on our YouTube channel, and we'll let you know so you can link to it. So with that, I'm going to thank Roger and wish everyone a good evening. And it sounds like it's time to get into 6 minutes. So, good hunting.